To help you with this next test, I gave you a review sheet that is entitled Matrices plus a review of chapters 1 through 5. Well, the purpose of this video is to help with those problems that are the review of chapters 1 through 5. And so I've started here with number 14, which is a review of lesson 1-4, going way back to near the beginning of this year. And we don't really do these word problems well, and I want to just re-emphasize some key tips, key phrases that I think unlock how to get to the answer. It's actually a two-part answer. So first of all, let's take a look at this last sentence, which says write a linear model. Anytime that you see write a linear model, or you might see it as write a linear equation, means the same thing, you should immediately think of the most commonly used linear equation, at least for us, is slope-intercept form. So seeing the word linear or write a linear model should drive you to immediately just write down y equals mx plus b, because that's what your answer, the first part of your answer, is going to look like. The difficulty for some is determining what is the number that's going to go here that we call m, or slope, and what's the number that's going to go here. That becomes really the big part of this problem, is figuring out what these two numbers are. Alright, so let's focus first of all on how we can get m, or slope. If we can get two ordered pairs out of this paragraph, or these three or four sentences, then that would be great, because we already know, given a couple of ordered pairs, how to find the slope. You learned back in Algebra 1, maybe even pre-algebra, that if you're given 2 points on a line, you can find the slope by using this little formula. y2 minus y1 over x2 minus x1. Okay, well, with that said, since we have this little formula that can be easily used to find slope, let's see if we can come up with a couple of ordered pairs, making sure that we arrange the numbers that we're given in this problem in the correct order. It is important that we treat the numbers that are supposed to be x, we put them in the right spot, and the numbers that are supposed to be y's, same thing. Well, let me show you how you can always know, if you're given these sets of numbers in a problem, how do you know which numbers represent the x variable and which ones represent y? And it's all about what the problem is asking you to do. To me, these three words in this problem unlock this entire problem. Predict the year. Okay? Given, notice how a certain number of feet is given. Okay, so look at it this way. Unknown for a certain given. Whatever it is that the unknown is currently, that it's our job to figure out, that represents y. In this case, years we can label as y. Alright, so whatever it is, look at what the problem is asking for. And whatever it is that the problem is asking you to determine or to figure out, you can go through your problem at that point. In this case, for years, every time you see a year, you can put a little y above it, if that helps. Because that is what the problem is asking for us to determine or figure out. Alright, so the unknown in the problem, it's your job to figure out, that's y. That means this given number, which is in feet, will be the x. So every number that I see in this problem that talks about feet from the water, I'm going to put a little x above it. Okay, so now it makes it pretty easy to see how I can come up with a couple of ordered pairs. Alright, in this little phrase right here, I have an ordered pair. I just have to rearrange them because I have to make sure x goes before y in the ordered pair. So out of this phrase, I'm going to have the ordered pair 430, 1990. Jumping down a little bit further, I see another ordered pair written in this little phrase. X is 400, y is 2000. And now I'm off and running because, again, this is how I find the slope. y2 minus y1. I'm going to call this y2, and this will be y1. So 2000 minus 1990 divided by, okay, if I call this y2, then I've got to call this x2. 400 minus 430. All right, I get 10 over negative 30, which makes negative 1/3 when it's simplified. That is my slope. So far, I'm halfway there to getting the linear model. I know that the slope is negative 1/3. How do I figure out what the y-intercept is? Well, just like you learned in the past, if you know what the slope of a line is and you know at least one other point on the line, you can substitute all of these numbers. M is slope. Pick one of these ordered pairs to plug in for x and y. Doesn't matter which one. And all that's left then will be b, and you can pretty easily solve for b. So I think I'm just going to go with this bottom ordered pair and let 2000 be y. 400 will be x, and we already have the m. We solved for that already. That's negative 1/3. So 2000 equals negative 1/3 times 400 plus b. All right, and for this one you might want your calculator. So when we do, we'll just change this to decimal. We're basically saying 400 divided by negative 3, and that's negative 133.33 repeating. I'll just round it off to 2 decimal places. Plus b. And now it looks pretty easy to solve for b. I'm going to add 133.33 to both sides, and I get 2133.33 is my b. And now I've got all I need to write the linear model. Okay, so here is my model. And please don't forget on your test to write this, because it's really worth more of the points in this problem than the actual prediction. All right, so my model is y equals the slope, which was negative 1/3, times x, plus the y-intercept, which is 2133.33. So there's my answer to the linear model, and now let's use it to make the prediction. So what that involves is taking this given number of feet. Remember, in my problem, x represents feet. I've already labeled 2 other measurements in feet with the variable x. So I'm just going to take my model and I'm going to replace x with 250. And we're going to figure out what that year is. So we can grab our calculator, and that's the same thing as 250 divided by negative 3. And we add to that 2133.33, and we get 2049.996. But again, this is supposed to be a year, so we're just going to round to the nearest year. And so when we take 2049.996 and round to the nearest year, we get 2050. So let's put some context, some wording to wrap this up, because we're answering this, basically this phrase here. In what year will the house be 250 feet from the water? So we're going to say in about, since I rounded, in about the year 2050, the house will be 250 feet from the water. And that is the conclusion to that problem. But don't skip this. A lot of people are jumping right into trying to figure out what the final answer is without giving me a linear model. And this is important, that you're able to take information and model it with algebra. All right, so that's number 14. Okay, now we get into some parent functions with their translations. So let's run through those quickly. The line y equals x. Get my line draw tool. Y equals x. You should be familiar with that at this point. That's a line that passes through the origin because the y-intercept is assumed it's 0. The slope is 1. So we can draw it like this. It basically looks like that. That's y equals x. I'm a little bit below, but it's not always easy to. Yeah, it's better. Okay, so there's y equals x. Remember that anytime you put negative in front like this, that serves the effect of flipping the parent over the x-axis. So that would make this graph. And then this is a translation. Translation means shift or relocate or transplant. There's several different ways of thinking of translate, move. This is taking the parent and shifting it 3 places down. So all of the points on the parent would go down 3, and it'll look something like that. And so there's 15 through 17. All right, this is the absolute value function, the parent function. Remember the v in value, that's a clue because they always produce v shapes. So remember the parent, you can always identify the parent because the coefficient of x is always 1, and the parent function always has a vertex at the origin. I'm going to do 2 arrows when really it should just be 1, but I'm not going to change that. So there's the parent. This means we flip the parent over the x-axis. We reflect is the technical word. And then here is a translation of this parent. And remember, inside the absolute value walls, this is the horizontal translation. Here's how we describe translations in general. Whatever h is means a horizontal move. In this case, h is 2, positive. So I'm going to move 2 places to the right. K means how I'm going to move vertically. Positive 3 means up 3. So I'm taking the points on that parent and I'm shifting them right 2 and up 3. And it looks something like this. All right. Very good. Now let's do the quadratics. Remember quadratic, the u in quadratic, the u and the word squared. These are parabolas. I noticed that some people are just drawing random u shapes like that. But you need to draw through specific points. The vertex will always be at the origin. But just think of input 1 gives you output 1. Input -1 also gives you output, or just think of the y-axis as being your AOS. Input 2 gives you output 4, and so we can match that up with the AOS. And so this is the more precise parent function graph. And this is flipping that parent function over the x-axis. Oh, missed that one. And this is taking the parent that we drew over here and shifting it, or translating it 3 places to the right, to the left, 3 places to the left and 1 place down. All right, so we start with the vertex here at the origin, just like the parent, and every one of the points on the parent will go left 3 and down 1. Okay, that includes this one. left 3, down 1. And now our symmetry line is here where the vertex is. Alright, 2, 4 was on the parent, but we're going to go left 3 and down 1. And those dots represent the translated parent. Okay. Square root of x. Remember, the domain for this is all of the numbers that are greater than or equal to 0. It would not be allowable to input something like -4 because that's not real. So therefore, the square root function, the square root parent, starts at the origin where x is 0, and then it goes to the right. Not just randomly, but we just use perfect square root numbers to get some easy points, like input 1, output 1. Input 4, output 2. Input 9, output 3. So those represent points that we can use for the parent. Again, if we take the parent and flip it over the x-axis, that's the effect of the negative sign here. So we still will start at the origin, but this time we're going to reflect. We're going to be down underneath for -2 and 9, -3. So here's the reflected parent. And now here's back to the parent, but we're going to shift it 2 places to the right and 3 places down. So start here where the parent starts and go right 2, then go down 3. And that's true for every one of these parent points. Okay, so here's a parent point. Just take it right 2, down 3. All right, 4, 2 is another parent point. Take it right 2, down 3. 9, 3 was a parent point, so right 2, down 3, and there's the translation. Okay, that takes care of the square root, and now let's do the cube root function. Here's what the parent looks like. Think of some perfect cubes. Of course, if you do input 0, the cube root of 0 is 0, so input 0, output 0. Cube root of 1, input 1 gives you output 1. And now this time we can input negative numbers. The cube root of -1 is -1. Alright, so another perfect cube number is 8. If you input 8, the output is 2, so 8, 2. And if you input -8, you get -2. So here's the parent cube root function. Try to draw it here. Looks something like this. When you put negative in front of it, it just flips it over the x-axis. So it makes this shape, this graph. 1, 2, 3, 4, 5, 6, 7, 8, 2. So you can see how it kind of turns around and goes the other way. And now here's a translation. Just follow your same translation rules. Start with the parent. You can start here at the origin if you like. And this means to go left 1. And the outside number means to go down 2. And just do that for every one of your parent points. So here's a point on the parent, 1, 1. Left 1, down 2. -1 was on the parent. So let's go left 1, down 2. 8, 2 is on the parent, so left 1, down 2. -8, -2 is on the parent, left 1, down 2. And so this is the graph of the translation of the parent, y equals the cube root of x. Okay? So far so good. And have a few problems left. Back in, let's see, this was chapter 3, lesson 3.7. We learned how to solve quadratic inequalities by graphing. Well, let's take this and put it in equation form, because the first thing we have to do is get the graph of this parabola. Okay, so there's a couple of ways. This one just happens that it can be factored. That's not always going to be the case. If factoring isn't possible, you'll need to use the quadratic formula. But I'll go ahead and show this one as the factored form. So the factors of 3 that add up to -4 are x minus 3, x minus 1. So the solutions to this quadratic equation are 3 and 1. Well, remember, solutions to a quadratic equation are the same thing as saying the x-intercepts for the graph. So I can go ahead and put 3 and 1. I know that my graph is going to pass through those 2 points. I know the graph opens up because the number in front of x squared is positive. So now I know that the vertex has to be somewhere down here in quadrant 4 because it opens up through these 2 points. Now I've got to find the vertex. Now since I know where these x-intercepts are, I can just split the difference because I know that my AOS has to be right in the middle of these. But you could also use this little formula. This is how we find the AOS, opposite of b over 2a. The opposite of -4 over 2 times 1. So this would be -2, but when we do the opposite, it makes +2. So I know the AOS is x equals 2. Let's draw a little dotted line here to represent the AOS. I have symmetry on either side of this line. And the vertex then I will find by plugging 2 back into this function. Just treating it as though it said f of 2 equals x squared minus 4x plus 3. And that's 2 squared minus 4 times 2 plus 3. 4 minus 8 is -4 plus 3 is -1. So the vertex is 2, -1. I can do another point. Remember, the constant at the in this quadratic function is always the y-intercept. So that's always a nice one to plot. It's easy. So here's the graph of the parabola. Okay, and now let's work on, now that we have the graph, we can go back and look at the original inequality. And what this says is for this graph that is represented, where or what part of the graph is below. When it says less than 0, it means below the x-axis. If it had said greater than 0, then it would mean what part of it is above the x-axis. Okay, well, it's pretty obvious that the part that's below the x-axis is right here in red. And what are those x-coordinates? Well, the part that's below the x-axis falls between x equals 1 and x equals 3. And it doesn't include because it doesn't say less than or equal to. So the way we can write our answer then is all x such that x is between 1 and 3. If it had said greater than 0, then we'd be looking at this, and we'd say all the numbers less than 1 and all the numbers greater than 3. But since it wanted to know less than or below the x-axis, then we just show all the numbers between 1 and 3. There's your answer for number 30. All right, 31. This is a polynomial function, 4th degree. Let's find the end behavior. Well, we talked a little bit about end behavior first semester. Some things that we know just by looking at the function. First of all, you should always pay attention to the lead coefficient. That's the number in front of the very first term if they're in order, standard form. The number in front of the first term, the lead coefficient, if it is positive, lead coefficient positive, then your graph has to go up forever on the right side. That's always true. If this had been negative in front of x to the 4th, then your graph has to go down forever on the right. So the sign in front of the very first term will tell you what happens on the right. Positive number, it's going to go up on the right. Negative, it's going to go down. Now we look at the degree. The degree will always be the highest exponent for x. And it's even. Well, we mentioned in the first semester that if the degree is even, then the left side will match the right side. An easy way to remember it is if the degree is odd, then it'll do opposite. Just think odd, opposite. Well, this is even. So since it goes up on the right side, it's got to also go up on the left side. They will match. Okay, so let's put it all together in the language that we used for end behavior. The way we describe going to the right, we say as x, as we travel along the x-axis to positive infinity. That's another way of saying as we go to the right along the x-axis, how are we traveling up or down? Well, we've already established that it's got to go up. So f of x, or y, is also going to go to positive infinity. As we go right, we will also go up. Now what about left? As we travel along the x-axis to negative infinity. Well, since this is an even degree function, we're going to go up on the left as well, because remember they have to go the same direction since it's even. So f of x will go up or positive to positive infinity, just like it did when it went to the right. So that's the answer for the end behavior. To find the zeros of a function, since we can't factor and there is no, this isn't quadratic, so we can't use the quadratic formula, we're going to use the rational root test and synthetic division. We set up a little table. And remember, we use the coefficients across the top. And down the side, we're going to test numbers that are factors of this last number. The factors of -8. Plus minus 1, plus minus 2, plus minus 4, plus minus 8. And I'm just going to start with 1. And we're trying to find which one of these numbers gives us a 0 remainder. And that is a 0. If a number gives us a 0 remainder, that's this last column, then it is a 0 of the function. So let's see. Bring down the 1, multiply, add. 1 plus -6 is -5. Now just keep repeating that. -5 times 1 is -5, plus 7 is 2. 2 times 1 is 2, plus 6 is 8. 8 plus -8 is 0. So kind of fortunate there. We got a 0 right off the bat. One of our 4 zeros is the number 1. So what remains, the numbers to the right represent a cubic function. X to the third minus 5x squared plus 2x plus 8 equals 0. So we're going to go through this table again. Alright, so let's just make a little table. This time we're going to use 1, -5, 2, 8. We're still testing those same factors. I know it says +8, but that's the same as the factors of -8. Now let's think about this for a second. If it took +1, if +1 ended up giving us a 0 remainder when it was -8 on the end, it may stand to reason that if we use -1, it'll give us a 0 remainder when this is +8. Let's see. Bring down the 1. -1 plus -5 is -6. +6 plus 2 is 8. -8 plus 8 is 0. So we found another 0 of the function. So we're halfway there. We found 2 of the 4, and now these numbers represent a quadratic. Notice we're just going down by 1 degree. We started at 4th degree. We brought it down to a 3rd degree. Now we're down to a 2nd degree, or quadratic. And when you get to quadratic, you don't need to use the table any longer. You can, in this case, you can factor. If you can't factor this, then of course you're going to have to use the quadratic formula. But this factors pretty easily. And that makes it easy to find the other zeros. X equals 4, x equals 2. So here we have them, all 4 zeros. 1, -1, +4, +2. So the answer to letter C is, what are the x-intercepts? Well, that's another way of saying the zeros of a function as long as these x-intercepts are real numbers. Okay, so for example, if we got down to here and either one of these or maybe both of these were not real, maybe we got down to the end and we got something like this, plus minus 2i. Well, then I only have 2 x-intercepts in that case, because these, the imaginary numbers, do not count as x-intercepts. There's no way to plot an imaginary number on our real number Cartesian plane. So if I ended up with something like this as zeros, they would be zeros all right, but they would not be x-intercepts. But the way our problem ended up, all 4 numbers, all 4 zeros are real numbers, so they end up being our x-intercepts. So my answer for letter C will just be these numbers again. Not only are they zeros of the function, but since they're all real, they're also the x-intercepts of the graph. And then finally, letter D, the y-intercept, that's always easy. I've already circled it. The y-intercept is always the constant at the end of the function, and that's -8. If you're not sure, you always plug 0 in for x to get the y-intercept, and if you do, all these terms will drop out. It'll just leave you with -8. There's your final answer for 31, and then we just have one more. 32, if f of x is 2x minus 10, g of x is given as this. This is known as a composite function. And the way this works is you always work inside out. So the first thing you need to do is find out what is going on in here. What is g of 3? G of 3 means I'm going to input 3 into this g function, and I'm going to see what comes out. So you notice how I replaced both of the x's with 3, and now I'm going to simplify. 3 squared is 9, plus 9, plus 1. 18 plus 1 is 19. So the way this, the phrase I like to use is the output from the inside becomes the input for the outside. Okay, did you catch that? The output from the inside becomes the input for the outside. So 19 is going to become the input for the f function. Alright, and we multiply before we subtract, so 38 minus 10. My final answer here is 28. Okay, so I hope that helps. I know some of these problems you haven't seen in a while, but we're going to keep doing review as we go throughout the year. I don't want you to forget this stuff, and the more you practice it, the easier it will be to come back to you after you've been away from it for a while. So I hope that helps. If you have any questions, let me know.